That is, we need to find the Fourier transform of f of x is equal to 1 when the value of x lies between minus a to a. Okay, or we can say it as mod x is less than or equal to a. That's one and the same, and it is 0 when x is greater than a. And hence we need to evaluate these two cases. That is, first evaluation is from integral from minus infinity to infinity sin as into cos sx divided by s into ds, and second thing we need to evaluate is 0 to infinity sin s by s into ds. Okay, so now let's write the solution part. That is, we know that Fourier transform is represented as f of x into e power isx into dx. Okay, so we know that in order to evaluate these two cases, we need to first find the value of the Fourier transform, and after that we need to use the inverse Fourier transform to find these two values, since we have solved a similar kind of problem in our first problem of this module, right? So in the same way we are going to solve this also. F of s is equal to, the limits are now from minus a to a. So, similarly in the first problem we have solved it, right? That is from minus infinity to minus a. We have to take it as one interval, that then we need to take it as from minus a to a, and then at the third interval we need to take it as from a to infinity. Here we know that whenever x is greater than a, the value of f of x is 0, right? So I am not writing that integral itself. Okay, so we will be left with the one integral, that is from minus a to a, where the value of f of x is equal to 1, right? So I'm directly writing it as e power ixx into dx. So it is 1, right? So yeah. So now we need to integrate this function, that is e power isx divided by the coefficient of x here is is, and the limits are from minus a to a. F of s is equal to, substitute the limits, that is e power is into a by is minus e power minus a, so minus of is into a by is. So now f of s is equal to e power is into a minus e power minus is into a by is, right? So now we can see that this is again of the form of the function, that is, we know that sin n theta is equal to e power I theta minus e power minus I theta divided by 2i, right? But here in the denominator 2 is missing, and also we have an extra s term, and in the numerator in place of theta we have it as s into a. Okay, so now in order to bring this 2 here, we need to multiply the numerator and both numerator and denominator by 2. Okay, so the final answer will be looking like this: e power isa minus e power minus isa divided by this 2 comes inside 2is into 2. So now this is of the form sin n theta, right? So in place of theta, that is, there is a into s. So the final answer is f of s is equal to 2 is there, right? 2 into sin as divided by, there is an s here down. Yeah, so this is your required f of s. Okay, so now we are going to evaluate the two cases. Okay, so the first case, for this we need to use the inverse Fourier transform. That is, we know that f of x is equal to 1 upon 2 pi from the integral minus infinity to infinity f of s into e power minus isx into the parameter is now ds. Okay, so now substitute the value of f of s we have got here, minus infinity to infinity 2 sin as by s e power minus isx into ds. So here we can cancel this 2, so the remaining term left here is 1 upon pi minus infinity to infinity sine as by s into e power minus isx into ds. So now before moving further, please make a note of this general term here. Okay, so since we need this term to solve the problem also, that is e power minus of I into theta, right? That has a general form that is equal to cos theta minus I sin theta. Okay, so here in this integral we have it is of a form e power minus I sx, where here theta is equal to s into x, right? So this becomes cos into sx minus I sin into sx. Okay, so in the integral we have this term, right? That we are going to replace it by this term. Okay, so now what will the problem look like? Yeah, so it's of the form 1 by pi into minus infinity to infinity sine as by s. So here we had e power minus isx, right? So that I have replaced it by the general formula that we have used. Okay, so now 1 by pi from minus infinity to infinity. So now multiply these two terms. Okay, multiply these two terms. So we get it as sine as into cos sx by s. See, now we are getting nearer to the solution. We've got this term, right? Along with that we have another term, that is minus I sin as into sine into cos sx by s. Into ds. Okay, sorry, this is sin sx. Okay, yeah. So now in order to move to this in this problem further, we know that we have got this term, so we have this term extra here. Okay, so whenever we have any extra terms, and also this is not an extra term, if we observe carefully, in along with this term we have an imaginary term. So whenever in an integral if we get these kind of problems, right, where we stuck in this position, where in an integral we have a real term as well as the imaginary terms. So in order to move further in this problem, we need to neglect this imaginary term. Okay, so this whole imaginary term we can cancel it. Okay, we need to always neglect the imaginary term. Okay, so the required f of x would be looking like this. We need to consider only the real parts, that is sine as into cos sx by s into dx. Okay, so now multiply this, take this pi to another side, so this will become to pi into f of x is equal to minus infinity to infinity sine as into cos sx by s into ds. So yeah, we've reached to the solution, and this f of x, we know that in the question it is given as f of x is equal to this, right? That is f of x is 1 when x lies between minus a to a, and 0 when x is greater than a. That only we are going to substitute here. We have to keep that as it is, that is f of x is 1 when a and 0 when x is greater than a. That is equal to minus infinity to infinity sine as into cos sx by s into ds. So pi into f of x, right? So now multiply this pi with these two terms. Okay, so the final answer would be looking like this: sine as into cos sx by s into ds is equal to, multiply pi inside, so this would be equal to pi when x lies between minus a to a, and it is 0 and x is greater than a. So this is your required first case. We have got the answer, right? So we have two answers for this case. Integral from minus infinity to infinity sine as by cos sx by s into ds is pi when x values lies between minus a to a, and it is 0 when x is greater than a. Okay, so yeah, this is the first case. So now we are going to consider the second case. So now, in order to solve the second case, we need to consider the values which we have got in the first case, that is this integral. Take this as equation 1. So in order to further proceed in this problem, in this equation, if you observe carefully, in order to get this term right, sin s by s, how we can simplify this term in order to get this term? So here we need to substitute few values, that is, if we substitute the value of a as 1 and x as 0 here in this integral, we automatically get it as sin s by s remains. See, if values of a is 1, so this is equal to sin s into cos into 0. Cos 0 is 0, right? Anything into 0, 0 into cos s is 0, divided by s into ds. Yeah, we are getting the same. So here now what we need to do is, in this equation, put a is equal to 1 and x is equal to 0. Okay, so now this equation will be looking like this now: minus infinity to infinity. The value of a here is 1, right? So sin s by s into ds. So this, if x is 0, so cos 0 into cos s, that is again 0. So that term would get cancelled, is equal to pi. Because when it is 0 when x is greater than a, right? But here the value of a is strictly 1. Okay, so the value here, the only pi remains here. So now again this term we need to check whether it is an even function or not, in order to split the integrals. That is, if it is an even function, we can write it as integral from minus infinity to infinity is equal to 2 times of 0 to infinity. So now f of s, consider it as, we've solved it. So now consider f of minus s minus sine of minus s, sine of minus s divided by minus s. This is not there. So sine of minus theta, it's equal to minus sine theta. So this is minus sine s by minus s. Minus minus gets cancelled. So it is equal to sin s by s. It matches with the f of s. So this is an even function. So now the function would be looking like this, that is minus infinity to infinity. Now it is written as 2 times of 0 to infinity, right, into sin s by s into ds is equal to pi. So now bring this pi to the 2 to the another side with along with pi, in order to, so that we remain with only this term. So this would be looking like 0 to infinity sin s by s into ds is equal to pi. Here there was 2, right? I brought it here. So this is your required answer. So this is your second question, that is, we need to find the Fourier cosine transform of the function f of x, which is given as e to the power minus ax. Also we need to evaluate the integral from 0 to infinity cos kx divided by x square plus a square into dx. Okay, so now for this we know that first we need to find the Fourier cosine transform of this function, and whatever we got it as the Fourier cosine transform, with the help of that we are going to find its inverse Fourier cosine transform, so that we reach the evaluation case which we are required to do. Okay, yeah, first thing we are going to solve is the Fourier cosine transform. It is given by fc of f of x is equal to 0 to infinity f of x cos sx into dx. So now f of x is e to the power minus ax cos sx into dx. So again this is of the form e to the power ax cos bx plus c. So now let's directly write the answer, that is e to the power minus ax divided by a square, and in place of b there is s, so s square into a cos bx. So in place of a there is minus a cos sx plus s sine sx, b sine bx, and c value is 0. So and the limits are from 0 to infinity. Again in here we are going to take 1 by a square plus s square as common, and e to the power minus ax as common for both these terms, minus a cos sx plus s sine sx. Limits are from 0 to infinity. So now let's apply the limits. The upper limit is infinity, so e to the power this becomes minus infinity, minus a cos infinity plus s sine infinity, s sine infinity into the lower limit is minus e power 0 minus a cos 0 plus s sine 0. So here e to the power minus infinity is equal to 0, so this whole term is 0 and sine 0 is 0. So the remaining terms are 1 by a square plus s square into minus is again plus e power 0 is 1 and a into cos 0. Cos 0 is again 1. So the remaining term is, so the final answer we get is a by a square plus s square. Okay, so now with the help of this a by a square plus s square, we are going to solve the inverse Fourier cosine transform, so that we are going to get this answer. Okay, yeah, so we need to evaluate this. For that, use the inverse Fourier cosine transform. The formula is fc inverse of fc of s is equal to, the formula is given as 2 by pi from 0 to infinity fc of s into cos sx, since it's a cosine Fourier transform, so cos sx, and the parameter here is ds. So this is also equal to f of x, right, as per the definition. Okay, so now we are going to replace this by f of x, so we can directly write it as f of x is equal to 2 by pi from 0 to infinity fc of s cos sx, and here the parameter is ds. So but in the given question, we have the question in the given, it is given that f of x is equal to e power minus ax, right? So now directly we are going to write the value of f of x, that is we are going to substitute here it as e power minus ax is equal to 2 by pi 0 to infinity. What just now we have got the Fourier cosine transform, that is a by a square plus s square, right, cos sx into ds. So now bring this 2 by pi to the other side, cross multiply. So this would be pi by 2 into e power minus ax is equal to 0 to infinity a by a square plus s square cos sx into ds. If you observe carefully, in the evaluation case we need only cos kx divided by x square plus a square. So we can see that we have here cos sx and a square plus s square. This a is disturbing us, so we can consider this a as constant and we can take this to the other side. That is, if we take this a first outside the integral, that is a into 0 to infinity cos sx divided by a square plus s square into ds, and now take this a to other side, that is pi by 2a e power minus ax is equal to 0 to infinity cos sx divided by a square plus s square into ds. Okay, so now we need to make some changes in this equation. Now in this equation, that is we need in the numerator, in the evaluation, in order to evaluate we need cos kx, right, cos kx we need, but in the numerator we have it as cos sx. So now first we are going to replace the value of x. X is equal to k. Okay. In this case, in the whole equation, now we are going to replace the value of x is equal to k. So now what will the whole equation become? Pi by 2a e to the power minus a, and now x is replaced by k, right? Now it will be e to the power minus a k, 0 to infinity cos s, and the value of x here is k divided by a square plus s square into ds. Now the answer is not done yet. We need cos kx in the denominator now. We have cos, we have k, but in place of x we have s, right? So now that's the only thing left here. So now since s is the parameter, right? So we can replace the value of s, that is put s is equal to x. So now finally if we substitute the value of s is equal to x, we get it as cos k. Now s is replaced by x divided by a square plus s square, so it will now become x square into dx, right, is equal to pi by 2a into e to the power minus a k. So this is your required answer for the evaluation. Find the Fourier transform of f of x is equal to e to the power minus of a square into x square, where a is greater than 0. Also we can say that a is a positive constant. Okay, so let's get to the solution part. We know that the standard value of f of x, we have solved two problems, that is equal to minus infinity to infinity f of x into e power isx into dx. Okay, so now substitute the f of x value, e power minus a square into x square into e power isx into dx. Okay, therefore the f of x value whatever we get, that is equal to minus infinity to infinity e power minus a square x square plus isx into dx. Okay, I have just added the powers. I have just added the powers. So now let's solve. Minus infinity to infinity e power, let's take minus sign outside here. Okay, so let's write it as minus of a square x square. So if you take minus outside, this becomes minus, right, isx into dx. Okay, so now whatever is there in this bracket, right, that is minus of a square x square into minus of a square x square minus isx. So we are going to replace this by something else. Okay, so now what we are going to replace it by? Okay, so now I am making a table here. So if we solve by keeping this term, right, it's going to be difficult for us to reach the final solution. Okay, so now we need to replace the value of a square x square minus isx is equal to ax minus is by 2a the whole square plus s square by 4a square. Okay, so how we got this solution? We need to replace the value of this by this. Okay, so how we got this? We got this by the method of completing square. Okay, this method we have used in our 10th standard problems most of the times. Okay, so now how we got to this solution? So now I'll write the proof here that this term is equal to this term whatever is there in the bracket. Okay, so and prove this term such a way that this term would be equal to whatever there in this bracket, that is a square x square minus isx. Okay, I'll reach to this solution by taking this term. Okay, so now first thing what we need to do is, that is a minus b whole square identity, use this and write it as a square, that is ax the whole square, that is equal to a square x square, right, plus 2 into the plus b square, right, So is by 2a the whole square, that is equal to I square s square divided by 2a the whole square is equal to 4a square, right? Minus 2ab, that is 2 into ax into is divided by 2a. This is not axis, okay? All are different variable names, so please don't confuse it with the word axis, okay? Axis, that is 2 into a into b plus s squared by 4a square, keep it as it is. So now we can cancel this 2 here, we can cancel this a here. So what is the term left? That is isx, okay? So here also a square x square plus, we have here I square, right? We know the value of I square is equal to minus 1, right? So substitute that, minus 1 into s square by 4a square minus isx plus s square by 4a square, that is equal to a square x square plus into minus is minus s square by 4a square minus isx plus s square by 4a square. So we can cancel this minus s square by 4a square and plus s square by 4a square. So whatever the terms are left, that is equal to the term which I have written here, right? It's equal, right? Yeah. So for this case now, whatever is there in this bracket here, I am going to replace it by this value, okay? So now let's see how the sum on the terms will look like. That's equal to e power minus of this term, okay? Ax minus is by 2a the whole square plus s square by 4a square into dx. Now we know that the powers here in this bracket are added up. So now let's split that and we'll write it as minus infinity to infinity e power minus ax minus is by 2a the whole square into e power s square by 4a square into dx, okay? Sorry, minus is there, right? So minus gets added up to 4a square into dx. So now this term is there, right? Let's take it outside as a constant term. So in order to make our problem easier, so I'll tell you that how it will be easier for us. So take this term outside of the integral, that is e power minus s square by 4a square into the interval from minus infinity to infinity e power minus of ax minus is by 2a the whole square into dx, okay? So now replace here in order to make the problem easier, let's take the value of ax minus is by 2a is equal to t, okay? So now we'll differentiate in both the sides. So now what it becomes, the differentiation of x is dx, right? And this is a, that is constant. So constant differentiation upon the is, so this whole term is constant, so this is 0 is equal to the differentiation of t is equal to dt. Therefore we get it as dx is there, right? That is equal to dt by a, okay? So now the problem is e power minus s square by 4a square, right? Into the integrals are from minus infinity to infinity e power minus this ax minus is by 2a is equal to t, right? We have taken it as t and it in the question it is whole square, so this is become minus t square into dt by a. Dx is replaced by dt by a. See, I have written it right. Dx is equal to dt by a. So now take this a also outside, constant. So this becomes e power minus s square by 4a square divided by a into the limits from minus infinity to infinity e power minus t square into dt. So now while we observe this carefully, this corresponds to a standard value. That is, this corresponds to a gamma function. I don't know if you people have heard it or not, but this has a standard value, that is from minus infinity to infinity e power minus t square dt is equal to root pi, okay? So make it keep it as a note here. This has a standard value, okay, since it is called as a gamma function, okay. So same thing now, nothing much to do. We need to substitute this value as root pi and we get the final answer, that is e power minus of s square by 4a square divided by a into root pi. So this itself is your final answer for this question, okay. So please make a note of this. We have we have substituted some values in such a form that we get the term that is from minus infinity to infinity e power minus t square dt, so that we can solve the solution for this problem becomes easier. Otherwise this problem is a bit lengthy. So this problem can be asked for an exam as well. This is a repeated question, okay. So yeah, this is the answer for this solution. We need to find the Fourier sine transform of f of x, where f of x has the three following values, that is f of x is 4x when x lies between 0 to 1, and it is 4 minus x when x lies between 1 to 4, and it is 0 when x is strictly greater than 4, okay. So now we'll apply the formula for Fourier sine transform. It is given as fs of f of x is equal to 0 to infinity f of x sine sx into dx. So now we are going to split the limits, that is from 0 to infinity, right? So first we are going to write it from 0 to 1, then 1 to 4, then greater than 4, so 4 to infinity. So now f of x is given as, now first interval is from 0 to 1. Now in 0 to 1 the value of f of x is 4x, right? Sine sx into dx, plus now the interval is from 1 to 4 and the f of x value is 4 minus x sine sx dx, plus 4 to infinity, the value of f of x is 0 sine sx into dx. So here we have 0, f of x is 0, so 0 into anything is 0, and the integral of 0 is 0 itself, so this term we can neglect it. So now for these two terms we are going to solve this, okay. So take this 4 outside and do the Bernoulli's rule for the rest of the function, that is x, right? First function as it is into the integration of second function, that is minus cos sx by s, minus the differentiation of x is 1 into the integral of integrated function, that is minus sine sx by s square, and the limits are from 0 to 1, plus the second function, that is first function as it is into the integral of sine is minus cos sx divided by s, minus the differentiation of 4 minus x, differentiation of 4 is 0 and minus x is minus 1 into minus sine sx by s square, and the limits are from 1 to 4. So now apply the limits, that is 4 into the upper limit is 1 into minus cos s, right? Value of x is 1, so s by s, plus sine s by s square, minus into minus is plus, minus the lower limit, that is 0 into cos 0 by s, right? Plus again minus into minus is plus, so plus sine 0 by s square, okay. Plus for the second function apply the limits again. 4 minus the upper limit is 4, so 4 minus 4 into minus cos x is 4, right? So it is 4s by s, minus into minus is plus, and plus into minus is again minus, sine 4s by s square, minus the lower limit, that is 4 minus 1, 4 minus 1 is 3, and here we have minus, so minus 3 cos x is 1, so cos s by s minus sin s by s square. So again, minus into minus is plus, and plus into minus is minus, so this is minus sin s by s square. Okay, so now we can cancel few terms here, that is 0 into anything is 0, right? So this is 0, sin 0 is 0, so this term gets cancelled. So 4 minus 4 is 0, so along with that this whole term would be 0. Okay, so now let's write the remaining terms. 4 into minus cos s by s, right, plus sin s by s square, bracket close. This 4 is only for this integral, not for the whole one. Okay, minus, plus into minus is minus, so minus sin 4s by s square, minus minus plus 3 cos s by s, again minus minus plus sin s by s square. So now multiply 4 to these two terms, that is minus 4 cos s, right, by s, and plus 4 sin s by s square minus sin 4s by s square plus 3 cos s by s plus sin s by s square. So here we can see that this and this we can group it together. Cos s by s is common, and minus 4 plus 3 is minus 1, and 4 sin s by s square plus sin s by s square, that is equal to 5 sin s by s square. So now we can write the final answer. So the final answer is minus 4 plus 3 cos s by s, right? It is equal to minus cos s by s plus 5 sin s by s square minus sin 4s by s square. So this is your final answer.